Chapter 15 in AP Environmental Science deals with water resources. Water, of course, is a very important commodity, something we can't live without for more than 3 days. The reality is a lot of people don't have access to clean, fresh water. So let's dive into this and talk about some of the problems that we have with fresh water. And first of all, a little case study. As you can see, the Colorado River, which starts way up in here near Boulder, Colorado, actually goes through Utah, through Arizona, Nevada, and down. It should end up in the Mexican Baja region. The problem is we've done lots of things, including putting dams on this system, and it's rerouted the water. We grow lots of thirsty crops in this region. Thirsty crops are those that require lots of water, like strawberries, because in regions like where we live, we like to get those strawberries throughout the year, so they're growing it. The problem is they don't have enough water really to satisfy their own drinking needs, much less that of thirsty. So what's happening is the Colorado River, which flows about 2,300 kilometers through 7 U.S. states, it includes 14 dams and reservoirs. Dams and reservoirs, something we'll talk about in a bit, but what happens is we're rerouting that water. Water supplied is from mostly the snowmelt of the Rocky Mountains. It supplies water and electricity for about 30 million people, so that is an upbeat side, including Las Vegas, Los Angeles, and San Diego. Of course, the most famous dam is the Hoover Dam, and it is responsible for irrigation of crops that help feed America. The problem is, by time the Colorado River gets to the Gulf of Mexico, there's very little water. So that has a harsh effect on the estuary, where that fresh water meets salt water. So the Southwest, of course, has recently been seeing more and more droughts. And you can see the picture of the Hoover Dam there, which has created a huge reservoir behind it, and negatives to that. Do we have enough usable water? We're using available fresh water unsustainably by wasting it, polluting it, underpricing it as an irreplaceable natural resource. Keep in mind, as something we'll talk about later, lots of fresh water goes into things like mining and agriculture and producing food. The amount of water that goes into simply raising a cow and processing a cow is amazing. Freshwater supplies are not evenly distributed throughout the world. Even in the United States, 1 of every 6 people, of course, on the planet does not have adequate access to clean drinking water. Kind of a little picture here that shows the mean annual precipitation throughout the planet. If you look at the United States, the eastern part of the United States, of course, gets much more rainfall than the western part. The thing is, the western part of the United States has much better weather year-round, so we're trying to grow a lot of what's called, again, thirsty crops there. You can see in North Central Africa, the Sahara, they don't have water. Very scarce. You can see the Middle East, where a lot of people live, doesn't have a large amount of water. Again, take a look at these. A lot of them have to do with desert kind of areas. A lot of them, if you take a look at the regions, particularly like along the western coast of the United States and California, you can see there's a desert because of the rain shadow effect because of mountains. So that really affects a lot of people. Concerns globally. Fresh water really is irreplaceable. Water does cover 71% of the Earth's surface, but a majority of that, of course, is salt water, of which we cannot use unless we do something like desalination, which costs a lot of money too. It's a very poorly managed resource. It's a global issue. It's an economic issue. It's a national and global security issue, because the idea of a nation is to keep care of its population, and if you don't have water, you're not taking care of your population. And obviously, if you take a look at what's actually available to us, it's only about 0.014% that we have readily that we can access in groundwater, lakes, rivers, and streams. Most of it's trapped in ice caps, or it's, of course, salt water, which we can't drink. It makes us more thirsty. Hydrologic cycle, of course, very important to us, which we studied before. Movement of water in the seas, land, and air, driven by solar energy and gravity. The solar energy is what creates faster moving molecules, gets up in the atmosphere via evaporation, and of course will be pulled back down via gravity. It is distributed unevenly. We alter that hydrologic cycle big time by withdrawing the water from the ground. Particularly, we pollute it. Climate change on this also. Couple things to dive into is groundwater and surface water are very critical resources. Think about where you're standing, the ground below us, of course. We have a couple different zones that we need to know. The zone of saturation, that's when we have spaces or the porosity in the soil is filled with water. So you can see on the bottom picture right here, we've got these little particles right here of sand, silt, or clay. And the porosity is the area in between it. That is saturated with groundwater. At the top of that level, we have what's called the water table. And of course, the water table can go up and down depending on how much moisture we get. The aquifers are something we're going to talk about in the picture coming up, but an aquifer is very important to us because we get a lot of groundwater from them. So here's a little look at aquifers and a couple very important things here that you need to know. First of all, we have a very defining layer of clay. Now, if you remember back to clay, clay is a very small particle, and it holds water really well, but it also is very hard to permeate. So what happens is, if you can think about, it's raining here, and the rain goes into the ground, it saturates, and of course that happens in our region very well, and it goes down into the ground. That is called an unconfined aquifer. If we go a little bit deeper, we have a layer down here called a confined aquifer. It's confined by the clay layer. So what happens is the clay right here does not allow this water from above to permeate down. That's a good thing overall, because what happens is if we have contaminants in that unconfined aquifer, they won't reach the confined aquifer portion, and that's where a lot of our water actually comes from. So if you live in a city that has well water, they have drilled down probably 300-400 feet down, and they're tapping into that confined aquifer. Think of it as kind of like a sponge. There's not a free-flowing river system underneath there, but that water is trapped inside the particles of sand, silt, and clay, and what happens is that porosity allows water to be there, and we're pulling that out and drinking it. Surface water is, as it is, surface water. It's things like rivers, lakes, and streams. Think about a watershed, so the Mississippi Water Basin, for example. What happens is the surface water right here we can access also. Some regions, of course, need to pull their drinking water out of rivers. The regions around the Great Lakes, of course, pull a lot of water off of that. What's interesting about this is as water goes down a system like this, they're going to get what's called lateral recharge. So lateral recharge is when water literally goes out into the side and then it recharges the groundwater system, which we can draw from. Two-thirds of the surface runoff is lost by seasonal floods. So in regions, especially coming from mountains, when we have where a lot of areas are actually supplied with water, like in Arizona, Nevada, California, if they get some flooding, that is going to wash right out and, of course, end up in the ocean eventually. Reliable runoff is a very important term. That's the remaining about a third which we can rely on. So year after year after year, that mountain runoff from snow melting is something that's reliable for the states out west that they can get every year. The reality, though, is what do we use it for? Agriculture is the biggie. About 70% of that reliable runoff goes to agriculture, so growing our food. That is a huge amount. The next is industrial use, cooling machines, processing, cleaning. Domestic, that's us. Only about 10% of our reliable water goes to us. Agriculture counts for about 92% of humanity's water footprint. So overall, we put a lot of water into this, and of course that causes some significant problems. A lot of that could be fixed because, again, we're growing thirsty crops. Virtual water is that's not consumed. It's used to produce food and other products. So virtual water, think about when you bite into a strawberry or an orange or an apple or watermelon. That's deemed a virtual water. It's usually used to produce food. Just a couple things. An eye-opening chart is it takes this many bathtubs full of water to produce 1 cup of coffee is 1 bathtub of water. The reality is we need to grow that coffee plant. We need to then harvest it, and then it's processed. In the processing, we use a lot of water, and of course, when you make coffee, you use water too. 2-liter bottle of soda, 3. That includes processing the plastic. Loaf of bread, 4. 1 dozen eggs, 14. Got to feed those chickens. And we got to grow the food that feeds the chickens too. 1 pound of cheese, 15 bathtubs, a hamburger, 16, t-shirt, 17, blue jeans, 72 bathtubs. We've got to grow the cotton or whatever the product is that makes up those jeans. Small car, about 2,600 bathtubs of water. And a medium-sized house, just to make your house, is about 16,000 water in the processing. Freshwater resources in the United States, more than enough freshwater, renewable freshwater, but it's very unevenly distributed, again, around the Great Lakes region. That area has lots of fresh water, but if you go out west or even down south when they have droughts, not so much. Think about where it's very, very heavily populated, like in Florida. What are the effects of the following? Well, floods, of course, pollution and drought, things we're going to talk about. The United States Geological Survey projection is that we have these things called water. These are actually the water hotspots that we're keeping an eye on. Take a look at California. In California, the Sierra Nevadas, of course, run in this region there. You can see in California, we'll do a little documentary a little later, but they're actually bringing water from Northern California to Southern in order to feed their very thirsty crops, or not only crops, but people too. So in this region right here, you can see where a lot of people live. They're very thirsty, very likely substantial conflict potential. This region here along the Colorado River, highly conflict potential because a lot of states are actually drawing from that. If we look at Colorado, where there's a high population and where we're withdrawing a lot, if you look down in southern Texas, right here, withdrawing a lot of that water out in order to grow thirsty crops and feed or give water to hot spots. Main factors that cause scarcity are things like dry climates, drought, too many people using an enormous supply of water. The case study, of course, of the Colorado River, people using that big time, and we're wasting a lot of water too. The UN, of course, projects, the United Nations rather, in a 2010 study that by 2025, 3 billion people will likely lack access to clean water, which is enough for everybody. These are regions that are stressed. Obviously, in the region of Central Africa, the Sahara, that's very stressed. You can even see in the United States closer at home where we grow a lot of food, stressed, high population and growing a lot of food in those regions. Look at Saudi Arabia and throughout the region, the Middle East into Asia, the stressed amount because, again, growing a lot of food to feed a lot of people. Another little graphic here is the percent of total population using improved drinking water sources. So these are the regions that kind of have clean water, which is a good thing. And of course, that's throughout North America, kind of into the Caribbean, South America. Yes, we have much better systems to clean our water. You've probably heard some situations too where if you go to Mexico on vacation, don't drink the water. Well, it's because they don't have adequate systems in order to clean their water. Europe, Russia, Australia, Southern Africa, very clean drinking, but still have problems. Accurate information about water shortages. The reality is we're withdrawing groundwater, we're building dams and reservoirs. These are things that possibly can help, possibly can hurt too. We're transporting surface water like in California, and we're converting salt water to fresh water. That's desalination. That's stuff we're going to talk about in the next lecture.